In winter, lakes exhibit a fascinating natural phenomenon where the surface freezes while the deeper layers remain in a liquid state. This behavior is governed by the unique thermal and density-related properties of water. As the ambient air temperature drops, the surface water begins to cool. Normally, cooling water becomes denser and sinks. This occurs until the water temperature throughout the lake reaches approximately 4 degrees Celsius, the point at which water reaches its maximum density. However, as the surface water continues to cool below 4 degrees Celsius, it becomes less dense instead of more, due to the anomalous behavior of water. This lighter, colder water stays on the surface, and once it cools to 0 degrees Celsius, it begins to freeze. The frozen layer that forms ice is even less dense than liquid water because of the hexagonal crystalline structure of ice, which spaces the water molecules further apart than in the liquid state. This lower density causes the ice to float. The floating ice layer acts as an insulating barrier, reducing the rate of heat loss from the underlying water to the cold air above. This insulation is crucial, as it helps to maintain the water temperature below the ice at a relatively stable level, typically around 4 degrees Celsius. This thermal gradient prevents the entire lake from freezing solid, allowing aquatic organisms to survive beneath the ice during harsh winter conditions. Another critical factor is water's high specific heat capacity, which means it requires a large amount of energy to change its temperature. This property further buffers the lake's internal temperature, reducing the rate at which it cools even when external conditions are frigid. This phenomenon exemplifies the interplay of thermal expansion, density variations, and molecular structure in determining the physical behavior of water. Without this anomaly in water's density, lakes could freeze from the bottom up, severely disrupting aquatic ecosystems. Instead, the combination of maximum density at 4 degrees Celsius, the insulating nature of floating ice, and the thermal inertia provided by water's specific heat ensures a stable habitat through winter. This remarkable behavior highlights the essential role of physical chemistry in sustaining life in cold environments.